Alright, so section 5.1, understanding linear functions. It's quite late here right now, just to let you guys know, so be graceful if I make a mistake, just bear with me. But 5.1, understanding linear functions, we're looking at what's a linear function, how do we recognize them, how can we see them in equations and charts and graphs, like what do they look like, what do they do for us. So we got 4 vocab words: linear function, linear equation, discrete, and continuous. First one we're going to look at is a linear function. So a linear function means that it is non-vertical, not straight up and down, straight line. So it's got to be straight, but it is not straight up and down. And I'll draw that in here. Not vertical. Alright, so we're going to first look at recognizing linear functions, and we'll go over the rest of these vocab later. So I've already drawn in a graph here. This graph is showing the distance in miles over a certain time period. Okay? And you'll see that I have 5 specific dots on this graph, but it is a connected line because, as we'll find out later, time and distance are both continuous things. Okay? So it is non-vertical, it's not straight up and down, it's got some slope to it, and it is a straight line. Okay, maybe not perfect, but it is supposed to be a straight line. So from this graph, we're already thinking, yeah, it's a linear function. Cool. So that's one thing that we're going to look for. We're going to add that down here is straight line on the graph. That's our first thing. Okay? But now we're going to actually take these points and make sure that we're all accurate. So take these 5 points that I got, we're going to transfer them to our XY chart. So this first point I have 1, 2, 10, 2, 4, 20, so 1, 2, 10, 2, 4, 20, 3, 6, 30, and so on, 8, 40, and 10, 50. Okay? And the other thing we're going to want to look for when we're talking about linear functions is we want to look to make sure that our x's are changing at a constant rate. We just want to make sure that as we're checking our graph, we know that everything needs to move at a constant rate in order for it to be a linear function. So the x's are all adding by 1. So far, so good. So let's put that under things to look for. Constant change. That's a delta symbol, but that means change. Constant change in x's. Alright, and now of course we need everything to be constant, everything to be changing constantly. So we're going to look at our f of x's or our y's here and look at how much they're changing by each time. So from 210 to 420 they're changing by 210. Okay, from 420 to 630 they're also changing by 210. From 630 to 840, 210. And 210. So, awesome. All of our y's are changing at a constant rate. They're always adding 210 each time. Basically, they're in a sequence. So, constant change in y's. Okay, so yes, what we just represented here was a linear function. Now, I do want to give us some just pictures of graphs that we can look at and see, are these linear? So I'm going to go ahead and erase these 3 pieces. If you still need them, just go ahead and pause the video. Okay, so we're going to look at 3 different graphs. And I just want to make sure we can identify which ones of these are linear and which ones are not linear. I changed my mind. We're going to look at 4 of them. Okay. So. Cool. So here's the 4 graphs. All we're deciding is, are these linear or are these not linear? So the first one kind of starts off looking pretty straight, but then it's got a curve Curves are not allowed. So, no, this is not a linear function because of the curve. Okay, the next one, we look at it, well, looks like a straight line, just got something funky happening in the middle, but it looks like a straight line. It's not vertical, but it has gaps. That's what we call this little circle right here, that's a gap. So no, this is not a linear function because of the gaps. Okay, this third one, so we look, looks like a straight line. It's not straight up and down, so therefore it has no gaps, it has no curves, therefore we got a yes. Okay. And the very last one, it does have a curve, so that one's also going to be a no because of the curve. We can't curve at all. It's all constant change, which means that everything's going to come out completely straight. Okay. Remember though, well, I won't tell you that. I'll have you guys try that. Alright, so I'm going to give you a couple to work on your own on the left-hand side. Okay, I want you guys just identifying, yes, they're a linear function, no, they're not a linear function. I'm going to give you guys 4 of them. And make sure you're doing these on the left-hand side. Make sure you draw out the graphs too on your left-hand side. There's absolutely no purpose to put it there if you're not going to draw it out, because then it's not going to help you out later. Alright, there's your first one. Second one. Third one. And the last one's actually going to be an XY chart. And I want you guys to use that XY chart just to make sure that everything's looking good. Cool. So yes or no, are these linear functions? Are they not linear functions? Complete that on the left-hand side. Okay, if you're back with me, I'm assuming you've already completed this on the left-hand side. So I'm going to go ahead and erase this and move forward. We're now going to stop looking at graphs, stop looking at tables, and now we're going to be looking at equations. So how do we recognize linear functions from equations? And the best way that I think you can do this is by looking at some examples and some non-examples. Because it's really hard to sometimes see the patterns unless you see enough examples. So I want to provide you with all those examples. So the definition says that it's an equation that can be written as ax plus by equals c. Okay, so let's just try an example, just pretty similar, that 3x plus 5y equals 10. Beautiful, that's an example of a linear function. Okay, 4x minus 2y equals -3. Beautiful. Okay, 2x equals 5 plus 2y. 6y equals x minus 6. Okay? All of those are examples of linear functions. A non-example, a nonlinear function, maybe things like 3x squared equals y. 3x squared plus 2y squared equals 1. Negative 1 over x plus 3 over y equals 5. So these are some examples and non-examples. So using these, if we try to generalize and think about what actually makes a linear equation, we want to be sure that, and I'm going to write this kind of in layman's terms, so it's not going to be as precise as maybe like the definition, but I want us to be able to use it. So it's a workable definition. So plane x and plane y. Okay, that's one thing we look for. Second thing we look for is no exponents on variables. Kind of ties into being a plane x or a plane y, right? And no variables in denominators. Okay. Alright, so if we look at all of these examples up here, the x's and the y's didn't have anything fancy going on with them. Plain x, plain y. No exponents, they weren't in the denominator, anything like that. Okay? When we get down here, the non-examples, we've got x squared, y squared, we've got some things in the denominator, so those are no good. So these are the things we're looking for to say, yes, they are a linear function. So I'm going to give you about 5 problems to work with right now, so make sure you have this down because I'm going to erase it. All of this should have been written on your right-hand side, and in just a second you're going to be working on your left-hand side. For these 4 equations, I want you guys just to tell me, just like you did in the last part, yes, they are linear functions, or no, they are not linear functions. Okay, tell me yes or no on the left-hand side. Are they linear functions or are they not linear functions? Alright, if you are back with me, I'm assuming you've already completed these 4 on your left-hand side. I'm going to go ahead and erase them now. And we are moving on to actually something pretty different. We're going to be talking about this world of discrete graphs versus continuous graphs. And we're going to think about kind of the simple way to figure out which one's which. So there's a couple different representations we'll look at. We're going to look at the graphical representation for both of these, as in what do they look like when I see them on a graph. So the continuous, kind of exactly what it sounds like, it's going to be a continuous line, right? Discrete is actually discrete little points on a graph, okay? So it's not a line connecting them, it's just points. And those are 2 completely separate types of graphs. Okay, and if we look at the definition of discrete, it says graph has unconnected points, perfect, they're not connected. Continuous, graph is an unbroken line with no gaps or breaks. Cool, that's what we've got so far. So let's look at some examples of both of these. So an example of a discrete graph might be something like the number of DVDs bought. Okay. Another example might be the number of shirts donated. Or another one may be the number of students at school. Okay? So try to start thinking about kind of what is it about these that make them a discrete situation? How do they seem similar? Number of DVDs, number of shirts, number of students. Okay, things like continuous might be the amount of water drinking. Okay, or maybe it is the number of miles maybe either ran or driven. Okay, something like that. So here's the big idea that we're going to try to take away from this. Discrete is something that you cannot have a partial piece of. You cannot have a partial piece of DVDs, right? You have to have a whole DVD or it's pointless. You cannot have a partial shirt. I mean, you can. Some girls wear like half of a shirt, but that is, we need to have full, like we're thinking full units. The number of students, there's no half students. There's no half of a person. You need a whole person, right? So these are whole units. You can't take them in halves. Continuous are things that can be basically in any measure. Halves, quarters, things like that. So the amount of water you're drinking. You can think about 1 cup. You can think about a half a cup. You can think about a quarter cup or anything in between. right? You could have drinking just a little bit of water, you could have drinking a ton of water, like anywhere in between works. So you can have half units. Okay, the number of miles driven. If you think about 1 mile, that makes sense. Okay, I drove 1 mile. If you think about a half a mile, well, that makes sense. I drove half a mile. Think about a quarter mile, all that makes sense. So you can think about these in sort of half units. So the big question is going to be, can I think about my situation with halves or half units? So if yes, right, if you can think about it in half units, if that makes sense, then it's going to be continuous. Okay? If no, if you can't have half units, then it's going to be discrete. That's kind of the big question that should hopefully kind of settle what the continuous versus discrete is. Alright, so last thing we're going to do here is I'm going to erase this. I'm going to give you guys 3 examples to work on the left-hand side, just deciding are they discrete, are they continuous. So if you still need this, go ahead and pause the video because I'm going to erase it. Alright, so the 3 examples that I give, make sure you write them on the left-hand side, and make sure that you are just writing to me, are they discrete or are they continuous? That's all I need to know. And we'll do 3 examples. Number of animals in the barn. Length of yarn that has been used. And the amount of pens Miss P currently has. Alright, tell me for these 3, discrete or continuous, for each one of these on your left-hand side. And that will complete your video when you're done with that.